Simpson's rule. So Simpson's rule is similar to the trapezoidal rule in terms that they both approximate the area under a curve. But Simpson's rule uses parabolic curves to approximate its areas. So let's have a look at the formula for Simpson's rule. So you might see it a few different ways, and they're all to approximate the area of some curve f of x between a and b dx. Now, you might see the area written as the approximation of b minus a over 6 outside of f of a plus 4 times the f of a plus b over 2 plus the f of b. It's not the way I like to do it. The way I like to do it is with using a is approximately equal to the height over 3 outside of y0 plus 4 times all your odd y values added together plus 2 times all your even y values added together plus the last y value, where just like trapezoidal rule, h is equal to b minus a over n, where n is the amount of subintervals you use. So n is your subintervals, and you always have one more function value than your subintervals. So we're going to look at approximating the area between 0 and 2 of the semicircle, which is root 4 minus x squared dx, and we're going to be using 6 subintervals. So if we have 6 subintervals, that means we have 7 function values. So we need to draw up a little table with 8 columns. Okay, and we're between 0 and 2. So let's work out the height. So we know the height is b minus a, so 2 minus 0 over the amount of subintervals, and we're going with 6. So our height is going to be 1/3, and that's what we need to add every time here. We need to keep adding a third starting from 0. So we'll get a third, add another third, we'll get 2/3. Add another third, we get 1. Add another third, 1 1/3. Another third is 1 2/3, and another third gets us to 2. So we've done that correctly. And now we can go ahead and sub all of these x values into our function to get all the y values. And if we do that, well, subbing in 0 gives us 4 minus 0 squared, which is 4, and root 4 is 2. Subbing in a third, we'd have a third squared, which is a 9th, and we'd have 4 minus a 9th, all square rooted, which gives us root 35 over 3. And if we keep doing this, we'll get root 32 over 3. Here we'll get root 3. We'll get root 20 over 3, root 11 over 3, and 0. Now we like to go label our y values, starting with y0, and it's really important if you're going to use the method I like, this second one here, to start off with y0, not y1, because that'll throw everything off. Then we have y1, y2, y3, y4, y5, and y6. And we're now ready to sub what we know into the formula. So we know the areas are going to be approximately to the height, which is a third, divided by 3. Outside of y0, well, y0 is 2, plus 4 times all our odd y values added together. Well, our odd ones are y1, y3, and y5. because 1, 3 and 5 are odd numbers. So we get root 35 over 3 plus root 3 plus root 11 over 3 plus 2 times all our even values. So our even values are 2 and 4. So 6 is also even, but it's also the last one, so we're just going to do y2 and y4. So we get root 32 for y2 over 3 plus root 20 over 3 for y4 plus our last y value, which is just 0. And that can actually all go in the calculator. And we get the area is approximately equal to 3.11.